All right, team. So this is part 4 of the final exam review. We're going to go over geometric series and piecewise functions. So we're going to start off with your summation symbol. So we need to figure out what all this means. So I'll give you a hint. We're going to be using this lovely formula over here to the side. Okay, so we're going to be using this along the way. So the first things we need to figure out, or we need to find the variables for that equation. So we need R, we need A, and we need N. So I'm going to write out R, A sub 1, and N, which you can also remember because it spells ran. R in this case is going to be found right here in the parentheses. It is the base of whatever your exponent, wherever you have an exponent, it's that base. So R is going to be -5. Okay, A sub 1 is our initial value. In order to find that, we need to take whatever our variable is equal to, which in this case is 1. We need to plug 1 in right here for the variable. So we're going to have -5 to the first power, which also equals -5. And then N we know because we need to count from whatever this number is to 8. So in this case, if we go from 1 to 8, 1, 2, 3, 4, 5, 6, 7, 8, we're going to have 8 values there. So we have our 3 important values that we need. We're going to be finding the sum of these 8 terms. Now I'm just plugging it in the formula. A sub 1 is -5. And then we have our parentheses, 1 minus R in this case is -5. Be super careful with your negatives. Okay, put everything in parentheses when you can. And then N is equal to 8, and then we have 1 minus -5. Best bet here is to plug this directly into your calculator, being super mindful of the parentheses. So you need to type -5, have a parenthesis, and then you need to have another parenthesis here to start it. Make sure the -5 is in parentheses. Close the top of that, close the top parentheses so you have all of that in the numerator. And then again, be careful of the parentheses down here. So when you do all of that, you're going to get that the answer is C. Okay, if you don't have a graphing calculator that's next to you, you can type this into an online calculator. Wolfram Alpha is a good one. Your computer, your phones have calculators, but when it's something like this, when you have a lot of parentheses, feel free to use an online graphing calculator or an online calculator, because sometimes it'll show you the format that you're kind of typing it in, so you can make sure that you're typing it in the way that you want to do that. All right, next one. Similarly, we need to find the sum. So we want to find our R, our A, and our N. So in this case, we know that R is going to be whatever's in these parentheses here. So R is going to equal 4. A sub 1, we need to plug in this value up here. So we're going to have 3 times 4 to the 1 minus 1, which means 1 minus 1 is 0, obviously. 4 to the 0th, anything to the 0th power is 1. So we're going to have 3 times 1, which is just 3. And then for N, we need to count from 1 to 7 to see how many values that is. That is 7 values. So we have our R, our A, and our N. Next, we're going to put that into our formula. So we have S sub 7 equals A sub 1 is 3 times 1 minus R, which is 4, to the N, which is 7, over 1 minus 4. Plug all that into your calculator, and that gives you, let me plug it in the calculator real quick. Three times 1 minus 4 to the 7th divided by 1 minus 4. And that should give you 16,383, which is D. All right, next one, it's asking us to find the sum when n is equal to 12. So again, we're finding our RA and N. So R, A sub 1, and N. We know N is 12 because it tells us that right here. A sub 1 is our initial value. So our initial value here is 6 because it's the first number in our sequence. And then R we need to find you can divide negative 30 by 6 and you're going to get that as negative 5. Just to double check, make sure that R is correct, take 150 and divide it by negative 30 and you should get the same number. In this case we get that number is negative 5. And then again we're going to use our formula. So S sub 12 equals 6 times 1 minus negative 5 to the 12th over 1 minus negative 5. Plug all that into the calculator and you're going to get B. All right, so for number 4, it's asking us to find the number of terms, which is different than what we were doing before. Before we were finding the sum. Now we're given the sum, and we need to figure out how many terms it is. So let's set up our formula. This time we are given a sum, and we're still going to set up our equation the same on the other side. A sub 1 is 9, 1 minus R is 5, to the n, we don't know n, over 1 minus 5. So we're solving for this variable right here. First thing you need to do is divide by 9. If we divide by 9 here, we're going to get 97,656 is equal to all of this right here. I'm going to go ahead and do another step. This 1 minus 5 is negative 4, so I'm just going to write negative 4 here. Do not combine this. You cannot make that a negative 4 to the n, okay? That is illegal, not correct mathematics, okay? You can only combine those if they have the same exponent. So, now at this point, we need to multiply by negative 4 to get it out of the denominator. So we're going to get negative 390,625 equals 1 minus 5 to the n. Okay, here we want to get that 5n by itself, okay? That way we can take the log base 5 and get n out of the exponent. But first we need to subtract 1. So subtract 1 over here, we're going to get... Ooh, I made a mistake. My bad. This is a 4, not a 5. I skipped a step. So that should be a 4. And then when we subtract 1, now it's going to become a 5. So you should have this. But we don't want a negative. We can't take the negative log. We're not going to take a negative log. So go ahead and divide by negative 1 on both sides to get rid of the negative. And then last but not least, we want to get that n out of the denominator, out of the exponent, so we're going to take log base 5 of both sides. Then this goes away, and we're left with n equals log base 5 of that. And then if you put that in the calculator, you would do that by saying log of this divided by log of 5. And when you type that in the calculator, you're going to get 8. Okay, so your answer would be 8. Now, if you were asked to solve this, this is my expectation for that, okay? But also, if you're given a multiple choice test, be smart about it, okay? look here and see what you could do. You need to find what value can fill in for n to get this. Okay, so you could also take these values, plug it in, see what value would get the sum that you're looking for. All right, for 5, we need to figure out which of these, A, B, C, or, D, is going to match this graph. Okay, so start with the easiest part of the graph. In my mind, the easiest part of the graph is this one right here. So we have an open circle here, a line at 3, and a closed circle. So let's look through and see which of these has that correct line. So we know it's going to be 3, and then at -2 we have an open circle. So that means it's going to be -2 is less than x is less than or equal to 0 because we have a closed dot right there. So remember, closed dot means it has the equal to in it, okay? And if it's an open dot, that means that there's no equal to. So let's look at our 4 options. Which 4 of these options matches what we're looking for? Does the first one? No, the first one, we're looking for no equals to here, but equals to here. This has equals to both places. So this is not a possible option. Okay, for B is possible. C is also possible. D, however, is not possible. Okay, so we can cross those out. Next, we have 2 options left, okay? One of them has a negative x plus 3 right here, and one has an x plus 3 here. Okay, so let's look at that line. Is this line negative x plus 3, or is it positive x plus 3? Well, let's plug in some values. So if we had, let's take this for example, -3. If we plug -3 in here, I'm going to change my color. If we put -3 in here, we'd have a -3 plus 3, which would be 6. Is our point right here -3, 6? No, it's not. Okay, so that's not looking good for us. But let's try it here. If we put in a -3 here, plus 3, does that give us 0? Yeah, and that point is at -3, 0. So that tells me that this is out. Okay, and then double check, make sure that all of your points match up, make sure all of the less than symbols, greater than, equal to, make sure all those open closed circles match up as well. If you look here, when x is less than negative or equal to -2, so this should be a closed dot, which it is a closed dot right there, so that's good. Then we have an open dot, closed dot, and then this should be an open dot as well. Okay, so our answer here is C. All right, so domain and range for this graph. Again, remember, domain is x values, x, range is y. So in this case, if we're starting all the way over here at the left side, and we're going to work our way this way, we have x values going all the way out here. So our x values stop here, but we still have our line continuing. And then when we stop here, our line still continues, and there's arrows. So there is no gaps in our x values, so this is going to go from -infinity to +infinity. Our range starts at the bottom and works our way up. So there's no y values down here. The first one is right here at -2. So we're going to have -2 in parentheses or in brackets, and then we're going to have a union because we're skipping all of this area right here. There's no y values there. And then our y values start here and they keep going and going and going and going and going and going. So really for our range, we're not even looking at this because our function right here tells us this is going to keep going and going and going. So then our range is going to go from bracket 0 all the way to infinity. All right, so given the piecewise function, this lovely function, find the following values. So we want to see when we have 3, f of 3, which one of these is 3 going to fall into? Is 3 less than or equal to -4? No, so it's not going to go in there. so it's not that one. Is x in between -4 and 1? No, it's not. But it is greater than 1. So that means that the answer is going to be 6. Okay, now for B, we want to find f of 0. 0 is going to fall between this one right here. So we're going to plug in 0. For x, we're going to have 0 squared minus 2, which equals -2. So the answer there is -2. For C, we're looking at -4. Okay, well, we have -4 two places. We have it here and we have it here. Which one are we going to be using? Well, we need to find which one is equal to -4. The equal to -4 occurs right here. So we're going to plug in -4 into this function, which means our answer is just -4 because the answer is just x. And then last but not least, get out a new color. 1. So if we find 1, again, 1 occurs here and 1 occurs here, but which one is the equal to? It's going to be the second function. So we're going to plug 1 in for x, and we're going to get -1. All right, and the last thing you're going to do is graph a piecewise function. So I'm going to be honest, at this point, your graphing calculator is your best friend. So what you can do is make tables. So I'm going to make this one blue. And I'm going to make an XY table for this function. So you need to find points, okay? But you need to find points that are less than or equal to 0. So we know our first point is going to be 0. And then the points after that are going to be less than 0. So let's use -1, -2, -3. So your options are to plug in these 4 x values into x and find y, which would be 6, 8, 10, and 12. Also, if you're more comfortable typing this function into the graphing calculator, then you can do second table and find the points. Either way, you just need these points. Then the next thing you want to look at is at 0, is this going to be an open circle or a closed circle? Well, it's less than or equal to, so that equal to means it's going to be a closed circle. So let's go ahead and graph these points. So we have 0, 6, it's going to be a closed circle, -1, 8, to -2, 10, -3, 12 is off the grid, which is fine. So here we're going to have a line going this way, going up with a closed dot. Okay. And then next we have x squared plus 1, but only when x is greater than 0. So let's make our table for that. We need to include 0 because we need to know if we have to have an open dot or a closed dot. But then greater than 0, we can do 1 and 2. Throw 3 in there as well. And this is for x squared plus 1. So plug in those x values. We're going to get 1, 2, 5, and 10. So graph these, 0, 1. We're going to have a open circle because it's less than. So we're going to have an open circle here. 1, 2, 2, 5, 3, 10. Okay, and be careful here. This graph is not a straight line, okay? It's a parabola, so make sure that you represent that when you're doing your graph. So this should look like this. It's just a sketch, doesn't have to be perfect. And then now, those are all the parts of our piecewise. So now we need to find the domain and range. So looking at our graph from left to right, this keeps going both directions. So our domain is going to be -infinity to infinity. And then our range, starting at the bottom, working our way up, our first y value is here, but it's an open circle, so it's going to be a parenthesis at 1, and it's going to go to infinity. And that is your review for geometry.